Hi all, let's start with the next video of PCIe. Till now what we discuss in PCIe in a transaction layer and its futures with scenarios, error scenarios. Then after we started with the data link layer. In this data link layer we discussed about what actually data link layer, what happened in the data link layer, what are the features will be there in the data link layer. So in that data link layer we discussed about ACK protocols related to as we discuss in a DLLPs, different types of DLLPs. We have a ACK protocols. What is the use case of an ACK protocols? We'll see in this video. Uh, ACK protocols means it's a ACK means it's kind of acknowledgement. NAC means no acknowledgement. Like we'll see one overview of that PCI layers once again. From the top layer we have a core. The core is initiated with a PCIe bus. In PCIe, we have a three layers in hardware side: transaction layer, data link layer, and file layer. So what happen? Whatever data instruction and data coming from the core transaction layer will generate a packets. So in the data link layer, it will do as a link packets we called as a these packets we called as a link packets. It will add as a sequence number and LCRs. What happen from the top layers, you will get as a data. Transaction layer, it will append a header and ECRC, header and ECRC. Data linker, it will add as a sequence number and LCRC. What happened? Let us assume you are getting data from the top layers. Transaction layer it's generated as a 10 packets. Let us assume 10 packets is generated. So each packet will give us a number, right? That we call as a sequence number and LCRC added from the data link layer. This we call as a link packet. This we call as a link packet. Once a data linker is added is a sequence number LCRC, this packet will send to the file layer. File layer which will add as a boundary condition. It's kind of start and end. When it start in when it will end the packet. So what happen? The whatever this packet will send to the transmitter. This is the transmitter. You will send the packets. Once sending this packet from transmitter to receiver, it will receive as a it will get to know like the receiver. This is will be the um, starting of this packet. This is a sequence number. Next we will see as a header, then we will see as a data. So receiver will get to know clear information. What is the next field, whether it is sequence number or LCRC, ECRC. So everything will very clear to receiver side. So that's why it's will adding as a start and end bits across the file layer. This is the main of packet formation of the what is the significant of packet in the each layer. So we'll see as a in data link layer one feature as a ACK protocol. So let's see the ACK protocol what actually happened. What is the use case of that ACK protocol? Let us assume you have a 10 packets. That 10 packets is generated from the transaction layer. Once the transaction layer is sent to the data link layer, every packet which will add as a sequence number and LCRC. LCRC link layer CRC sequence number is a 12 bits. LCRC will be the LCRC will be the here will be the LCRC is present. That will be the 16-bit. 16-bit LCRC, 12 bits sequence number. 12, 12-bit sequence number means 0 0 0 0 0 0 0 0 0 0 0 0. So 12 bits means 2 power 12 combinations. So 4096 packets for a we can give as a every individual sequence number. So this is the combination value. LCRC will calculate the based on that packet. Whatever data coming from the top layer, it will calculate the LCRC. So, what let us assume you have a RC, you have a EP, you are sending the packets from the RC to EP side. You from the RC to EP side, let us assume as a membrane. So In transaction layer, let us say you are sending as a 10 packets. So what happen? Transaction layer will generate as a 10 packets. Once 10 packets is generated, the data link layer will add as a sequence number and LCRC, right? Once the sequence number LCRC added, this packet will go to file layer, then it will transmit to receiver side. It will check the starting and end bit whether it is correct, then it will send to data link layer. Data link layer, what happen? Here will checks will happen. So what, let us assume you are giving sequence as a 1 2 3 4 5 6 7 8 9 10 like that. This is the sequence you are sending data from your transmitter to receiver. Once the receiving your data link layer will check as a what is the sequence number based on that L. First it will check the LCRC. LCRC. CRC is correct or not. First it will check. If it is okay, now it will see the sequence number. What is the sequence? Whether I receive sequence proper or not. First I have to get one right. If it is one, sequence number is correct, LCRC is correct. What happen? Once the LCRC sequence number is correct, that data link layer will send to acknowledgement to this transmitter side. I received as a sequence number 1 with LCRC. So this is a packet is correct. So that is we call as a acknowledgement will send. Acknowledgements will send to receiver data link layer to transmitter data link layer. Once the acknowledgement received, it will again it will send the next packet like that sequentially. So next you will get as a 3 4 like that. So once the acknowledgement is done, that packet will send to data link layer. So in this way you will get as a acknowledgement. If you are not received, LCRC is fail or link layer you have a some errors, you got an error, so data link layer will detect that error, that will generate as a NAC, send as a NAC. So NAC NAC information sent to the this data link layer to this receiver data link layer to transmitter data link layer. It will receive as a NAC with sequence number. This is a let us assume sequence number 2 got as a NAC. So what happened? So transmitter will understand like sequence number 2 got a NAC. So I have to send re I have to send again that packet. So by using what happen, whatever data coming from the transaction layer, first it's what happened. It will it won't send directly. Whatever data packet from the transaction layer, what happened here we have in a DL layer. Assume as this is DL data layer. We have a retry buffer. Before sending to packet into the file layer, what happened? That packet are also shared stored in the this buffer. If you get as a ACK information, that TLP is removed from the DL layer. If you get NAC from the file layer, receiver side to transmitter side, again it will send that packet. Let us assume scenario where you have a DL layer, you are stored the packets with a buffer with 1 2 3 4 5 so on up to 10 you stored in the DL layer. If you get sequence number is 1 ACK with acknowledgement as a ACK, then this packet will be removed. If you get a sequence number 2 with 2 with ACK, then it will be the removed from that uh, buffer. If you get a sequence number 3 with the NAC, let us assume you got a no it's a got an error packet, that packet get corrupted, so you got a NAC information from the receiver to transmitter side. So what happened that from using that retry buffer you can able to send data from the this DL layer to this receiver side, so no need to generate the packet again. Once the packet is generation is completed 1 to 10 packets, this all packet coming from the data link layer, this data is stored from the inside that DL layer of that buffer. So what happened, whatever packet you get a acknowledgement is correct, that packet is removed from that data link layer retry buffer. If you get a NAC, again it will send the packet to receiver side. So in this way the packet information will get to receiver side whether it is received correct or not. So we'll see the packet formation what actually happened. Yeah, as I explained in the DL layer we have a two types packet. One is a link packet. Another one will, as I told, as a DLLPs, data link layer packets. So it will generate as its own packet. Data link layer it will generate own packet. I already discussed these points in a previous video. What is the significance of DLLPs? So DLLPs it will generate its own packets. What happened based on this DLLPs? We will implement some features. One point will be the ACK. So in this video, we'll see the what actually use case of ACK. So by using acknowledgement, ACK, what happened from whatever data received from the transmitter to receiver side, RC to EP side, EP will give us information to RC side. I received as a correct packet. If it is correct, that packet will removed from the data link layer. In data link layer, as I told you, we have a buffer. That buffer will store the packets. Whatever data coming, let us assume you are sending 10 packets. 10 packets will generate only once in the TL layer. Once the TL layer will generate, that packets will send to data link layer. The before sending to file layer, what happened? That packet is stored in a retry buffer. That retry buffer will take care the what actually response I'm getting from the receiver to transmitter side. Based on that, it will remove or we have to resend the packet from your transmitter to receiver side. So in this way, you will get a useful of DLLPs. So all the information happen from the transmitter DL to receiver DL happen with ACK protocols only. This DLLPs only. In that we have a ACK protocol. So what type of, let us you have a start and end, we have a then 60-bit CRC. What type of acknowledgement you have to give? The double zero double zero will be the act related. 0001 double zero will be the NAC related. So we will get to know clear type. This is the 8 bits data. So 8 bits is replaced with the that information whether it is ACK or not. So if you see in a whatever data coming, let us, you have a one DL layer of transmitter, you have another DL layer of transmitter, you have a retry buffer with the sequence number as you may say 1 2 3 4 5 6 7. You have a receiver side, this is also del as you may say DL, this is also having DL. So you have a transmitter, you have a transmitter, you have a receiver, both side. So what happened, let us assume you are sending as a packet number 7 is the first. Take as a 1 year, 7 is a year. So one packet is sent from your transmitter to receiver. It will check as a ECRC and sequence number, whether it is sequence is correct, LCS is correct. Let us assume this is a sequence you got a correct. So you will get as a ACK information will send to the another side of DL. This is the ACK information. What ACK in ACK this packet what is the present? We have a type ACK type. What is the information? Yeah, ACK information. This is a reserved for future password. What is the sequence number? This is the one 16-bit CRC. This packet will send to from your receiver to transmitter side. Based on that ACK information, this packet will be deleted from the DL layer. So what happen if you delete? What happen? You can store more TLPs. Whatever this retry buffer will be the limited space actually. How many TLPs you want to store? If you have enough space, then only you can able to store. Let us say that is the maximum I can able to store only 4 packets from the TL layer. So once is deleted, one packet is deleted. If you get a hack, from the remaining packets will come to and store here. So in this way transaction will happen. So in this way you will get a ACK information from the receiver to transmitter side. Let us see the scenarios where what actually what happen if the error is happen. Let us assume scenario. I have a sequence number 4 got a NAC. So you will see as a type as a NAC and the sequence number is 4. From the you will receive from the receiver to transmitter side. So what happen, it will see the NAC will send right from your receiver to transmitter side. Again what happen, that packet will send to fourth packet to that transmitter. So fourth packet received means up to fourth is correct. It's not going to send again from fourth packet. This is an information like let us assume you got a error with fourth packet. You have to send again, so you will get as a acknowledgement up to 3 is correct, right? Then only you will get as a fourth as a error packet. So once you receive as the fourth packet is error, you will send from again that fourth packet. This we called as a by how you will get to know whether it is received correct or bad packet using DLLPs. So all the communication happening from one DL to another DL happen to that in that data link layer packets only. So it will generate from the one DL layer and it will consume here. So by using this, what happen? The integrity, the data integrity will improve. What happen? You will generate only 10 packets in only one time, but you will get a information based on that 10 packets, whether it is transmitter, receiver, proper or not. We get an error, all the information take care from the data link layer only. So what happened, the data integrity improved. So these protocols, so this is the one point I want to add here related to the ACK protocols. One more point will be the we'll see as one more point we called as a how many times it's happened. Let us assume you have a DL layer, you have a one more DL layer, you are sending as a fourth packet up to 3 is correct, you are sending as a fourth packet, you will you will receive as a NAC that fourth packet. Let us assume you send a packet with the DL layer, we have another side receiver side DL, you send as a fourth packet, you got a response as a NAC information you got from the receiver to transmitter side. Again it will send that fourth packet. So what happen? How many times it will repeat? Like whenever you are sending that power packet, you're getting a response as a NAC. Uh, uh, Up to 4 times will happen. Up to 4 times. So you can able to retry. This we call as a retry, right? Whenever you are once you sent from your transmitter to receiver, you got a NAC. Again, you are trying to send the information from your transmitter to receiver. This we call as a retry mechanism. Using retry mechanism, you can able to send only 4 times. You can repeat only 4 times. If you get a fifth time also same NAC with the same specific NAC number, what happen? You have to do the link training again. So once a retry will be the reaching to actually retry will be the 2 bits. 2 bits means 4 combination. Once receive as a 1 1 four times. So what happen? Link training will start again. So it's forcefully start a link training. This is happen forcefully. DL will tell to file layer. Please try to do as a link training once again. It will go again recovery state again. It will do as a link training. So in this way, retry mechanism will help you 4 times and retry buffer help you to increase the data integrity. How you will get to know information from DL to another DL using as a DLLP protocols. So in the in this way data communication happen from the one layer to one transmitter to receiver using a data link layer. So by using ACK, let's give us a quick overview what actually discussed in this video. Let's first step will be the reset. Reset will be the state. You have to reset the all layers. Once reset is done, you have to go with the link training. Once reset happen, link training. Once link training happen, what happen? The link training happen in a 5 layer. So 5 will tell to data link layer do as a data initialization, whatever buffers you are using, virtual channel, everything it will do as a initialization. Once the initialization is done, what happen? Once installation done, it will do as a configuration read and writes. Configuration read and once configuration read and writes, what happen? You can able to send the actual information from your transmitter to receiver. Let us assume as a actual packets that we call as a TLPs. So in this TLP, let us assume I generated as a 10 packets from the TL layer. So how we will get to know whether it is receiver is received 10 packets or not? That automatically will take care of using as a TL layer. So once TL layer is generated 10 packets, it will send to DL layer with those 10 packets. It will add as a sequence number and LCRC. So you will get, let us assume you are sending as a 10 packets. So first packet will send from your transmitter to receiver, RC to EP side. RC to EP side. So you will get as a acknowledgement whether it is ACK or not. Based on that, it will before sending into packet from one DL layer to another DL layer, we have a retry buffer. That buffer will store that packets, that are 10 packets. I- Once if you if you receive as a NAC, it will send again that packet. If you receive as a ACK with the sequence number 4, that fourth packet will be removed from the retrieve buffer. So again it will start, fourth is removed, right? So maybe it's that packet is removed from the buffer. So you won't see that packet from you cannot able to send that packet again. Already receiver got received with correct, then only we will get as a ACK, right? So we no need to send again. So from fifth onwards, again you can able to send the packets. So based on that ACK information by using DLLPs, you will get the information like how packets will received, what actually information you got, communication happen using DLLPs. So most from the actual data means TLPs. The acknowledgement response we are getting from the receiver to transmitter side, it's happening in DLLPs. So this is the main context I explained in this video. If you have any question, please let me know. Thank you.